And now going to number 3. Don't forget to like, subscribe, and share. We are Vision Plus. Number 3a says, if a function f of x equals to 2x cubed plus 6x plus 7 all over 8x squared minus 32. Find the value of x for which the function f of x is meaningless. This question is from functions, and the question is asking for the values of x that make the function meaningless. So to begin with, let me say, for a function to be meaningless, for f of x to be meaningless, in some cases we say undefined. So for f of x to be meaningless or to be undefined, the denominator should be 0. The denominator should be 0, or it must be 0. The denominator must be 0. Must be 0. So in other words, the values of x that make this function meaningless are those values of x that make the denominator 0. So to solve that, we simply need to find the values of x that make the denominator 0. So if you look at the function given, f of x equals to 2x cubed plus 6x plus 7 all over 8x squared minus 32. So our focus is always on the denominator. We need to find the values of x that make the denominator 0. So how do we get those values of x? We have said we need to get denominator being 0. Therefore, we equate the denominator to 0, irrespective of what is on the numerator. As long as you are looking for the values that make the function undefined or meaningless, do not look at the numerator. We always look at the denominator. So we equate the denominator to 0 and get those values of x that make it 0. And therefore, we shall just say 8x squared minus 32 equals to 0. This is a quadratic equation that you can solve using any method, but this is a bit direct because we can just take 32 the other side and we solve. But this is a quadratic equation that you can solve using any of the methods, from factorization to formula, completing squares, and to plotting the graph. But this question is basic, so you don't need to waste your time. Therefore, if I take 32 the other side, I will have 8x squared equals to positive 32. Then I divide both sides by 8. If I divide both sides by 8, I will have x squared being equal to 4. Then I take the square root on both sides. If I take the square root here on both sides, I will have show it here. I will have my x being equal to plus or minus 2, because the square root of any number is plus or minus, and then the exact root. So these are the values of x. Therefore, our solution, or the values of x, are x should be 2 or x should be a negative 2. These are the values of x that make this function meaningless, because if we substitute for them here, if we substitute for 2 here, 2 squared, 4. 4 times 8, 32. 32 minus 32, it gives us 0. That is, if x is that 2, if you get the denominator, we shall have 8 into 2 minus 32, and that gives us 0. If you get a negative 2, if x is a negative 2, then still we shall have 8 into negative 2, but squared minus 32. Still, this becomes positive 4 times 8, 32 minus 32 is 0. So the moment the denominator is 0, then the whole function becomes meaningless. And therefore, these are the values of x that make this function undefined. So that is the solution to number 3a. Never forget, we are Vision Plus, and comment, like, and share. Thank you. And now number 3b. Number 3b says, find the gradient of the curve y equals to 5x cubed at the point 2 and 5. The curve is defined by y equals to 5x cubed. And for us to find the gradient of the curve at any point, we need to find the gradient function. So what is the gradient function? The gradient function is dy dx, since the function is defined by y. So we need to find dy dx. This is what we call the gradient function. And this is the derivative of the curve. We find the first derivative. So we differentiate the given function of the curve to find dy dx, which is the gradient function. So our curve is y equals to 5x cubed. How do we differentiate? On differentiating, we are differentiating y with respect to x. So dy dx equals to, how do we differentiate? Using the method of powers and coefficients. We simply get the power, we lower it. And if we lower 3 and we get a number here, or a coefficient 5, then we multiply them. So here we shall have 5 times 3, and then x. Then we subtract 1 from the whole power, that is 3 minus 1. And now from there, we simplify. This now becomes equal to 5 times 3, 15, x. 3 minus 1 is 2. So we have differentiated the given function of the curve. Therefore, this is the gradient function. Therefore, the gradient function dy dx is 15x squared. Now, gradient function is important because it gives us, or it tells us, what the gradient of the curve at a given point is. So this is the general format for getting the gradient of the curve at any point. But we're given a point 2 and 5. So at the point 2 and 5, at point 2 and 5, at that given point 2 and 5, what is the gradient of the curve at that point? It means here we just say our gradient dy dx at that given point. This is the meaning of at a given point. Draw that bar. At 2 and 5 now becomes equal to, remember this is just a coordinate point. This is a point on the curve. This is coordinate on the x-axis. This one is on the y-axis. So this is x and this is y. So we just substitute for where we see x or y. But here it is predominantly x. So x is 2. So here we shall have 15. Our x is 2, but the formula says squared. So what is 2 squared? 2 squared is 4. So here we shall have 15 into 4. And then 15 times 4, 60. So the gradient of this curve at the point 2 and 5 is 60. Therefore, our gradient, which is m, is 60. And this is the solution to this number 3b. In case you would like to know more about curves and gradients, please, we have a full playlist under differentiation and its application. Find time and visit there such that these concepts are very simple for you. Otherwise, we are Vision Plus. What I'm asking from you is a simple share if these materials are adding value to your learning. Thank you.